Let's do some functions and operations on array. I'll take a capital A, create a Numpy array of let's take 2-dimension array and one more, one of 1, the other one is 1 2 3 4, and next I take 4 5. Yeah, okay, this is capital A array. Then next I'm going to create with b equal to np dot array, the same. Okay, I have forgot, so let's take to the array. Okay, this time 1 of 0, the other one as 1 of 1, 2 of 0, and 2 of 2. So this is my capital B array. Alright, we can apply the mathematical expressions on these arrays. Let's take a variable called result. Result equal to np dot exponential of a. Let's take this, and we get all the values have turned into exponential of an array A. So same thing we can apply with square root of a B, capital B. Let's run this. So here we have a square root values of B array, and similarly we can say square root, and one more is add of A comma B, capital A comma B. So this is what we got from A. So 1 plus 1 is 2, 1 plus 0 is 1, and 1 plus 1 is 2 again, 2 plus 1 is 3. So this is how we have added up both the arrays. Now we can have trigonometric methods as well, like these, np dot sine of A. So these are the values of sine A array values. Next we can also have tan of A. So yep, and similarly we can have cos of B, capital B. Okay, so this is how we get. And we can also have statistics, all the basic statistic expressions or functions. So take a look. Log of or covariance of A values. So this is what we got. And variance of B, capital B. So this is what the variance of capital B. And can also express mean value of A. So this is the expression that we got, the mean. And standard deviation as STD is represented as STD of A is this much. Alright, so this are the basics that we have seen, and we got many more on Numpy. Okay, then let's look into the other one, like for example A and capital A plus B, the arithmetic expressions on arrays. So here we got A plus B again, which is very similar to add method. And again we can say same as print of A minus B, or A star B and a star star is nothing but the exponential, and one more, that division. Okay, so this is how we can do arithmetic expressions. Also, we can have assignment operators on it, like print of a less than b. Is that a less than b? Then false, false, false you get. Or a less or a greater than b. Let's find out. Yes, some are true and yeah, few are very false. So this is how. Or we can just say a is equal to b. Then yeah, so yeah, some are true and most of them are false. So this is how we can create. And one more few methods like a dot sum, capital A dot sum. So we get 21. All the values of a are added, so we got the sum of total values is 21. Similarly, we can say a dot minimum. Minimum of the values is 1. And a dot max, the maximum is 5. Let's check out with a array, and yeah, the maximum is 5 and the minimum is 1. That is what we see. And the total yes, sum is 21 could be. All right, then we can also check out with like a dot minimum of only in a row, axis equal to 0 if you say. So this represents the row and we are checking the minimum of a. So is 1 1 1. So this is the first row which is very minimum, the rest are maximum of this. Similarly, we can go with the max of column. Column axis equal to 1 you need to say. So the column 1 2 4 5 is the maximum. This is the maximum column, but 1 1 3 4 is the minimum column. That is what we got. If we take out with same thing and we check with the minimum of the column, then we get the first row, first column. Okay, so this is the one that we can apply operations and functions. And one more we got is random. Let's take a variable small a equal to np dot random dot rand of 6 elements, and let's say a. So these are the values in a given shape. So these are the values. Random is it creates instance default random numbers, so it is filled with random samples, and from standard normal distribution we have to get something like this, np dot random dot rand n of 6 if you compare with the previous one. So these are the values from standard normal distribution. So these values filled with random floating point samples from the standard normal deviation distribution. Okay, let's take another variable c equal to, which are random integers. So random integers, so you get, so you have to take np dot random dot rand int. So you need to provide the range 3, 10 and the size equal to, I'm going to take 10, or it should not match, so I'm going to say is 8 and say c. So these are the values which are generated from random integers. So this is how we got the 10 values and ranging between 3 and 8. And also the same thing we can generate as same as previous one. rand int of a 6. But when you say alright, when you keep running this, you get individual numbers randomly. So 1, the next time it would be 5, and the next time it would be 2, and the next time, you never know which number you are going to get it. So this is how we get random dot random int for the single number. Alright, this is for operations and functions. The next time it would be reshape manipulation of an array.